Abhishek is a senior research software engineer in the Department of Engineering Science at the University of Oxford. And today he will share his experience of developing and maintaining and supporting the research software that is being widely used in academic research and industrial projects. So over to you, Abhishek.
Thank you. So let me share my screen. So that's it. And yeah, I hope you can see, you all can see my slides.
Yeah.
So, hello, everyone. My name is Abhishek. And today I will talk about our, if I can move this thing, sorry. Okay, I don't want this window here. So do you all see that on the right-hand side, there is a window with the participant? So I don't think I can move it.
That's fine. We can see your screen. We can see your slides.
Okay, excellent. So today I'll share my experiences of developing a research software in the last 4 years. So in our lab, our vision is to develop software that is widely used by people in academic research as well as industrial projects. And we also want to nurture open source ecosystem around this software so that the software itself is sustainable and has lasting impact. And then this vision is very nicely demonstrated by this diagram on the top, where we are a computer vision research lab, and then we build bridges with other departments, other academic disciplines, using open source software tools. We also communicate with commercial companies and help them use our tools. And then we have an open source community who also supports all these tools. So in the last 4 years, we have learned that to pursue our vision, our software should be easy to install and then set up. It should be easy to use, and then it should be easy to fix, modify, and extend this software. So this is what we have learned in the last 4 years. And then today in this talk, I will share how the development of a manual image annotation tool has been a valuable learning experience for us. So a manual annotation tool, as you can see on the right hand side in this video, is a tool that allows you to define and describe regions in an image. So now it's defining a region and then describing it with different metadata. So that is what a manual image annotation tool is. So we'll look into all these three key learnings in the subsequent slides. So let's first talk about easy to install and set up. So here is an anecdote from 2016 from our research lab. So a DPhil student in our research lab spent several hours to install and set up a manual annotation tool in a Mac laptop of another DPhil student who was from the humanities department. Now, the manual annotation tool was an essential part of a collaborative project that was happening between our research lab and then the Department of Humanities, and then therefore this installation was taking place. Now, being a computer vision lab, we need a manual annotation tool for almost all our projects, because we use these manual annotation tools to develop data sets that are used to train computer vision algorithms. Therefore, in mid-2016, we decided to build our own manual annotation tool because the existing tools were extremely difficult to install and set up for a non-technical user. So our requirements at that time were very simple to state, but it was very complex to deliver. So our requirements were up and running in less than a minute. So you should be able to install and set up the software in less than a minute. And it should be easy to use for non-technical users. So think about users who do not know how to follow complex installation steps. As we explored our options, we stumbled on the HTML, CSS, and JavaScript offline application platform offered by almost all standard web browsers in all operating systems. So this is what we came up with as an early prototype. So this is around 34 lines of code combining together HTML, CSS, and JavaScript. And this is a minimal image annotation tool. So let me quickly show you how it does its work. So what I'm doing is I'm selecting all this code. And then here I'm creating a new text document saying it's an HTML file. And then I copy and paste everything in this text file. So I just pasted it and now I'm saving it. So I close this window. And now I open this in a web browser. So I'm opening this file in a Firefox web browser. So you can see that there is an image. And then now I can click my mouse and drag my mouse around and then draw a box. And then at the bottom, you'll see the coordinates of this box. So I can draw many boxes. And then all the coordinates gets stored here. So going back to my slides, sorry. Okay, I have to, should be this one, yeah. So going back to my slide, the point of this demo was that with this 34 lines of code, you can build a basic manual annotation tool that runs in any web browser. Let me quickly explain to you what this code is about. So this one is the line which draws the image on the web browser. And the second one is it draws a canvas over the image. And then the top one here, this is a basic CSS that ensures that the image and then the canvas lies on top of each other. This line here, it ensures that the canvas has the same size as that of the image. And then the lines on the bottom, it records the mouse events like mouse press and then mouse up. And then this is how it records where you pressed the mouse and then dragged it and then released the mouse. This is what is essential to record the user interaction with the image. And basically, this is what you need to do, make a manual annotation tool. So that was quite exciting when we stumbled on this. And then in the last 4 years, what we have been doing is basically extending this minimal manual annotation tool in multiple ways, so that we have self-contained offline applications for annotation of images and then videos. In the screenshot in the bottom, I'm showing the file name and the file size of our application. And then you'll note that all these files fit in less than 400 kilobytes of the HTML file. And then they are all offline applications, which means that you don't need an internet connection to use these. And then as we had earlier defined our requirements, all these tools can be simply run by opening them in a web browser. So now I'll quickly show you a demo of these tools that I'm talking about. So this one should be. So the first one is image annotation tool. And then you'll see that I'm opening it in a web browser. And then that's all it needs to start, to install and to set up this application. It runs right away in any browser. And then you can start drawing boxes. You can define metadata as you want. And then you can export these in any format that you want. You can zoom into the image. You can look into the details of the image. So going back to my slides, the important point here is that all the things that you need in a manual annotation tool, you can have in this less than 400 kilobytes of offline application that is run in your browser. Maybe I missed to show another demo. So this is more interesting. So this is a subtitle annotator. So on the right-hand side, you see a video there. Let me reduce the volume so that we don't have echo. So this is the video. And then in the bottom, you'll see all the, I'm just zooming it a bit. So at the bottom, you'll see all the subtitle text. You can resize them. You can move them around. You can delete them. And then you can edit the text as well. So this whole thing is running as an offline HTML application, and then less than 400 kilobytes. So coming back to my slides. So what we learned is that someone has to spend time. It could be either your users who collectively spend countless hours in installing and then setting up your application, or it could be you as a developer who will spend a certain amount of time to make the whole process frictionless and then quick. For us, it was not a difficult decision because we knew that we wanted to have a software that is very easy to install and set up. And then that's why this choice of platform of HTML helped us gain this or fulfill this requirement. Now we move on to the second learning that we had, which is easy to use. Now, how do you make something that is easy to use? This is a very simple question, but and then also maybe sometimes simple to answer, but it is very difficult to come up with a concrete answer. We think you can make something easy to use by using it every day. So when we were developing this manual annotation tool, we were using it every day in our projects. So a lot of researchers in our lab, they use it every day to build data sets for computer vision, to train their neural networks, to develop computer vision models. So we were using it every day, and therefore we were learning what was missing, what is great about this software, and then what we need to do. The second is once you talk to the people who use the software, this gives a lot of insight into what needs to be done, what is missing, what is working well. So humans who use your software, they are the best way to get feedback on your software. So talk to them. That's very important. And then finally, when you hear all these things from people talking about their software, you have to act on them and then make sure that you are addressing the issues that people report to you. Our application used most standard HTML components. So almost everyone who uses the internet and who has used a website, they are familiar with the components that we use in our user interface. So that gives us an advantage that our users already know what certain tools in our application do. We always use the concept of minimalism and then simplicity to drive all our decisions. So we don't want to add things just because someone has requested it. We decide on whether that functionality breaks the existing simple nature of the tool and then the simple workflow that it supports. And then we are very careful to only use the features of the HTML platform that are supported widely by most web browsers, so that our tools run without any issue across all the different standard web browsers. And then we don't have much documentation, but the way we provide guide to our users is using this concise user guide that you see at the bottom here. That appears whenever you are doing something. So when a user has selected a region in an image, they get a guide at the bottom saying that what you can do with this selected region. we have found that this is very useful for users, and then that's why it appears most of the time. Because we designed our software tools from ground up, we have a lot of flexibility in designing anything that we want. So we handle our own mouse events, we draw our graphics, and then therefore we can build anything that we need in this application. And then before we release a version of our tool, a lot of researchers in our lab have already tested it many times and gone through the bug reporting, bug fixing. So our users mostly, they get to see something that is more stable and easy to use. And then our tool, the video annotation is not any different than image annotation. So this is the power that the HTML platform has given us. It can display any image and then any type of video without any issue. And then our application has lots of keyboard shortcuts, which makes the whole process very easy. If you want to make something easy to use, the recommended way is to have a user experience developer in your team who will help you develop a user interface that is easy to use and an intuitive and has an intuitive user interface. But because we didn't have a UX developer in our team, we learned this art by looking at multiple online resources. So for example, this MIT OpenCourseware was really very useful in getting the basics. And then there are a lot of material online that one can refer to. So, but this is very important that you learn the art of designing user interfaces and then developing the user experience. So this is very important. And finally, the third learning that we had in this software is that the software should be easy to fix, modify, and extend. Now, we have a lot of users who not only report issues to us, but they often contribute code to fix the issue. And they also contribute code to add new features that improve the software. A reason behind that is because we have made our code easy to understand. We have made our code open source, and then we have made our code more easily accessible to users when they are using this application. So as an example, we don't minify our JavaScript code. So minification is the process where you remove all the parts of a code that are not necessary for achieving the functionality of the code, but that are there for say, improving the readability of the code. So we don't minify, we let it be what it is, so that when you are using this application, and then if you spot an issue, you can, if you have the background, you can open the web debugging console, you can look at the element that is causing the issue, and then see what code it is calling. And then with some basic knowledge about JavaScript, you can easily fix most of the things. And then that's what we have been seeing with our users. As I said, we have developed everything from ground up. So we do not use any external libraries. So you only need to know the core JavaScript, the basic JavaScript, to understand our code and then upgrade this code to fit your requirements. Our code does not need anything other than a standard web browser. And then because we have highly optimized our code to only contain the things that we need, we can fit everything in a very small package, which is less than 400 kilobytes. So you can send this full application to your colleague in an email, and then they can get up and running in less than a minute. This is an ongoing process where we are always exploring ways to write code that improves understanding for other programmers who want to use this code or who want to fix this code. And this is an ongoing process, but we are always very careful about writing our code so that other people can understand them. As I said, we are an open source software, and therefore we have nurtured an open source ecosystem around the software. So we have an issue portal where people come and report issues, contribute their fixes, they request for new features there, and then this is the playground where they come and report what they have found. We also have a portal where users can contribute code and then help improve the software. And then so far, a lot of users have contributed code to our tools. Those were the three things that we learned. So to recap, to pursue our vision of developing software tools that is used in multiple academic disciplines and in different industrial sectors, we learned that our research software tools should be easy to install and set up, should be easy to use, and then should be easy to fix, modify, and extend for anyone. But of course, all these depend on there being a demand for the tools that you're developing. So if the things that you're developing is only for a small group of people, you may have different priorities, and then these may not necessarily be important for you. But for us, because we were targeting a larger group of people, larger group of users, these points proved extremely useful. So looking at my time, okay. So now we are in the final parts of this talk. And then where I want to talk how these learnings helped us pursue our vision. So if you remember from my initial slides, we had this vision that we wanted to our tools to be used in academic research as well as commercial companies. So in the last 4 years, a lot of research projects have used our tools for their research. So we know this because those researchers have written back to us, often thanking us for developing this tool, and then sometimes asking us questions. So therefore, we know that the researchers from these universities and many more all over the world, they are using these tools and finding it useful. A lot of companies have also contacted us because they want to extend this software and or integrate this software in their existing products. Sometimes they let us know that they have done this. Sometimes they ask us questions on what is the best strategy to include these tools in their platform, and then we help them. And then therefore we know that these companies, as well as many other companies, they are using our tools. And then most importantly, we have a lot of general users who just use it to do their work. And then since this software was released in 2017, it has been used nearly 4 million times by users all over the world. So we think that the steps that we have taken, the 3 points that I discussed, they are helping us achieve this vision of reaching people in different parts of the world, in different academic sectors, in different commercial sectors. So therefore, we wanted to share all these learnings that we had in the last 4 years, so that others who have similar vision and priorities, they can also gain from our experiences in the last 4 years. So that was it. That's what we learned, and that's what we wanted to share with you all. I'm very happy to answer questions from you. So back to you, Dave, and the control. Okay,
Great.
in the chat window, I see a question.
Yes, I was going to mention that.
Interested. The question is from Dave. So Dave asked, I was interested to understand your open source model. What license is it distributed under? How do you promote the application? Or has it built through word of mouth? Thank you, Dave. It's a very interesting question. So our open source model is based around the BSD license. So it's an open source license which allows unrestricted use of a software in commercial as well as academic research. So there is no licensing needed. And then therefore, any company, any research lab is free to use this software in any way that they want, or extend this software in any way that want. The second part of the question is, how do you promote the application, or has it built through word of mouth? So we usually give talks at summer school conferences. A lot of researchers in our lab, they use it. So when they write papers about it, they cite our tool. So that could be a way how people know about it. And we have seen that a lot of people not related to us, they write about this software and they make videos about this software. They create tutorials about this software online, about how to extend this software, how to use this software. So in general, people, when they like a software, when it is useful to them, um, they become your promoter. So they write about you, they tweet about you, they share about you, and then that's how it spreads. So in a way, it is through the word of mouth. But I don't have a recipe for how this software reached a lot of people. So yeah, I hope that answered your question, Dave. Okay, I have another question from Andrew. So Andrew is asking, are there any features you'd like to include in your tool that are limited by your choice of HTML, JavaScript? Or would you consider extending beyond HTML, JavaScript if necessary? So that's the question from Andrew. So far, we have not seen any limitations other than some of the constraints that are imposed by web browsers for the security concern. So for example, our application cannot access the file system. So a user has to select all the files that needs to be annotated using this tool. So we cannot do that automatically as you have commonly in applications. So that is a constraint. But I think there are ways to simplify this process. And then so far our users have been faring well with this constraint. In terms of other limitations, currently we are working to have computer vision models. These are deep neural networks that assist human annotators in the manual annotation process. So imagine that you are annotating a video, and in one of the frames you have drawn a box around a human face. Currently, you have to draw a box in multiple frames manually. So that is quite time consuming. But there are computer vision models that automatically track certain objects in different frames of video. So we want to use these models running in the web browser and helping the human annotator to simplify the annotation process. So currently we are working to have object trackers and then object recognizers running in the web browser itself to do all these tasks. But it is more challenging to implement these models in the web browser as compared to, say, other platforms like Python or TensorFlow. So that is a challenge that we are facing, but we are trying to overcome this challenge instead of abandoning the great benefits that the HTML platform has brought to us. We have one more question from Matthew. So this is the final question. We are already out of time. So Gabriel, can I answer this final question?
Yes, please go ahead.
Okay.
Yeah,
so this is from Matthew. So Matthew says, this is a nice example, but I wonder about packaging software that might have more complex dependencies. Not everything can be JavaScript wrapped in HTML. How do you fulfill the easy to install in that circumstances? Matthew, this is a very good question. So far, we have not found this problem of packaging. So far, we have been successful in packaging everything in a single HTML file that is less than 400 kilobytes. So it includes all the icons we have, it includes all the JavaScript we have, it includes all the CSS we have. it includes everything. If you open our application and then view the source code, you'll see that it is packed with everything. I hope that that answered your question, but I'm not sure. So maybe you can ask if that didn't answer your question. If that did, thank you very much, everyone, for giving me this opportunity to talk about our software. Thank you very much.